Hi guys, in today's session we will build our own enumeration utility, and I'm hoping while doing this we will learn how to use the current the Enum utility which comes with Elixir, and also learn how to actually implement something like that. Okay, so what I've done is I've gone ahead and I've actually looked at all the functions available in Enum, and you can see it's quite a big list. And to start off, what I thought would be a good idea was, if we could implement these functions, and then maybe if we have the time we can move on to the other ones. Okay, all right, so let's get started, right? I mean, I've actually started this. So I have here a mix application whose name is naive, and it doesn't have anything else. So let me open up the lib naive folder. I'm sorry, the file, right? So that's the file. And what I'm going to do here is I'm going to initialize a module, define a module here called enum. Okay, so I'll say enum. Okay, and let's say n enum. Okay, and the first thing I want is I want to be able to use the reduce function available in enum. Okay, and let's take a look at what reduce in enum gives us. Okay, so if we see, reduce is a function which takes 3 arguments, right? So I'm just going to copy that and paste it here, right? So it takes enumerable, accumulator, and a function. Okay, so we got that. All right, this is what we want to build. Okay, and this kind of a thing is very well suited for test-driven development, because we know what we need to do, and we can just write a few tests and get them passing, right? Okay, so let me open the naive test file, and all right, so let me open that in another pane, and I'm going to close this. Okay. So now we have a nice setup, and what we want to do here is we want to describe the reduce function from the enum module. Okay, and it's always a good idea to import all the functions from your module, the module which you're testing, because that makes it easier to just use the functions. Okay, so here the first thing I want to do is I want to say can add using reduce. Okay, it's a simple test, and what I want to do here is I want to say assert reduce, and what I have here is 0, okay, 0, 1, 2, right? So 3 elements, and what I want to test here is when I use reduce on this list, and the accumulator is 0, and I want to do something of similar to addition. So operand 1, operand 2, and I want to add these two. Okay, right? So that's a good test, right? So it should tell us if if this thing works, right? So now let's open up a new terminal, and here I'm going to run mix test. Okay, and it fails because enum is not loaded and could not be found. That's weird. We have enum. Oh, so the name of that is naive enum. Okay, and actually we can make it enum, and here say import naive enum, because it already has it's already a nested module, right? Okay, so now if I run it, the test fails, which is good, right? Because we have the red in the red green refactor. Okay, so it says expected true t but got nil. Well, actually, we didn't write our assert properly. So we want to say this should be equal to, and what is the left hand side? 0, 1, 2. So 1 plus 2 is 3. So now, if we run our test, it says left is nil and the right is 3, so it doesn't work, right? So let's actually implement our reduce function, okay? And so now there is a caveat here. We just want to do this for list, okay? So for now, I'm just going to say this module is going to work only for lists, okay? All right. So with that, we know. All right. So let's see how to do this. So we know that enumerable is going to be a list, right? And actually, before this test, let's write another test. It says reduce works for empty lists, or returns accumulator for empty lists, okay? Because it should do that, right? So if I say reduce with 3, and it doesn't matter what function I'm passing. Well, actually, let me use something else here. So with 1, then we should get a 1, right? So what we have here is we have an empty list. We are starting with 1, and since there is nothing in the enumerable, it should return whatever the accumulator's value is, right? So let's test that, right? So it should fail. So I'm gonna is there a pending macro like that? I'm not sure. Okay, so I'm just gonna comment this out, okay? And now our test fails, right? So this is actually a simpler test, right? Which says if we have an empty list, we should return whatever comes in the accumulator. So now I can go here and say, if the enumerable is an empty list, and we don't care about the function, we should just return whatever is the value of the accumulator, right? So now if we run this, it passes. Awesome. We are making progress, right? So we've got one scenario covered, okay? Now, let's move on to the next one, which says can add using reduce, right? And let's just say can add using reduce with a single element, okay? And here what we can say is, I'll say if I pass a single element and let's say the starting accumulator is 3, then it should return 8, right? Because 5 plus 3 is 8, right? So again, this is a simple, so what I'm trying to do is I'm trying to go from the easiest scenario to the difficult, to a more difficult scenario, and trying to get it work, okay? Now here I can say, so I have one element, a list with one element and an accumulator, and what I want to do is I want to do reduce, right? So here I have everything I need. I just need to call function with the first argument being the element, and well, actually the first should, okay, so if you look at reduce again, that should tell us the order, right? So here, if you look at this guy, the first element is the element from the current list, okay, so which would be EL, and the second is the accumulator, right? So when you call the function, you call it with the element in the list and the accumulator, okay? So we'll use that to drive our code, right? So this looks good, and so here we can probably change the wording from OP1 to X and from OP2 to accumulator, right? Because X is usually used to denote the current list element, okay? in anonymous functions. Okay, so that should work. I'm hoping that should work. If we run that, we have two passing tests. Awesome, right? Now, now what we can do is we can actually add it for 2 elements, right? So yeah, this is getting kind of stupid, but let's go ahead and do this. Okay, so here now I can say op1, op2, and now or we can probably say x1 and x2, and what we'll do is we'll get the value of the accumulator by the new value of the accumulator like that, and then we can return x2, right? We can pass x2 with the new accumulator value, right? So well, actually we should be writing this test only after we write a failing test, right? I'm sorry, the function, right? So here can add using reduce with 2 elements, right? So here I'll say 5 and 9. So that's 9 plus 3 is 12 plus 5 is 17, right? So now if we run our test, it fails. Yeah, that fails because there's not even a function which matches that clause. Okay. So now we're going to uncomment that, and hopefully this should make the test pass, and it passes, right? Okay. So now let's add another test with we'll say can add using reduce with multiple elements. Okay. And here what I'm going to do is I'm going to pass a list with 10 elements. Okay, so I'm going to say 1 to 10 enum to list, and so okay, so here we are using enum to do some testing, so that's a bit amusing. Okay, so what is 1 to 10? 10 is n into n plus 1 by 2 is 55. Okay, so this is, well, if I say a and if I start with 1, then this should be 56. Okay, or if I start with 0, this should be 55. Okay, so that actually looks better. So now if we run this, it fails because we don't even have a clause which a function clause which takes multiple elements. So let's fix that, and so here I'm going to say this is an enumerable, and so for now let's just return whatever is in the accumulator. Okay, and it fails because the accumulator is 0 and what we're expecting is 55, right? So so now, okay, now we can add a match for 10 an array with 10 elements, right? But that would be very stupid, right? Because doing it for 1, 2, 3, and for 10, for 20, for 100, right? So that is not the right way to do it, right? So there has to be a better way. Now we can use recursion to make this simpler, right? So if you look at the 2-element array, what we are doing is we are passing the first element when we pass the first element, we get the accumulator value, and then we pass that accumulator value with the second element, right? And so on and so forth. So here what I can do is I can say instead of x1 and x2, so we will do a bit of refactoring. Okay, so I'm gonna comment out this test and I'm gonna do some refactoring. Okay, because at this moment all our tests are passing, right? So what I'm gonna do here is I'm gonna say if this list contains one element and one and more elements, what we are going to do is we are going to get the new accumulator value, and we're going to call reduce recursively by passing the rest of the list and the new accumulator value and the function, right? So if you see, this should work, right? So if we run our test, it works, right? And let's check this a bit, right? So what we are doing is, we're getting the element, and let's see if this is even necessary at this point, okay? So if I remove this, what's going to happen? It's still working, right? So what we're doing is, whenever we get a list, if it is empty, we're just returning whatever is in the accumulator. If it is not, we're splitting it into a head and tail, and we're running the function, we're executing the function for the first element in the list and the accumulator, getting the new accumulator value, and then calling ourselves with this, with the remaining elements, right? And that should work for elements of all sizes, okay? So if I run it with 10, it works. Awesome. So we've just implemented reduce, right? So that is a good, that's a good thing. Now, all right, so what I'm going to do here is, I'm going to make a commit here. I'm going to get init, commit reduce is added, right? And, okay, so now we have reduce, and let's see if it works for multiplication. Can multiply using reduce with multiple elements, right? Okay, so if I start from 1 to, if I do 1 to 10, that is 10 factorial, right? And what is the value of 10 factorial? 10, right, so 10 factorial. So I'm just, yeah, it's 36288, some number, okay? So what I want to do here is, I'm going to say 1 to 10, if we multiply it, we should get this value, okay? And if I run it, it should pass, and it passes, right? So awesome. We've got the reduce working, and now let's go back to our to-do list and look at the remaining functions, okay? So now we have map, right? So the reason I did reduce first is reduce is something which can be used to implement almost all of the functions in Enum, okay? So now that we're done with reduce, let's implement map in terms of reduce, okay? So and let's just say map takes an enumerable, and and a mapping function, right? And if you think about it, what does map do? If you pass it 1 to 10, and if you say increment these numbers by 2, it is going to just run, run the function, mapping function for each element, and create a new list and return that, right? So we can actually call reduce enumerable, and the accumulator is this, and the function is, what's the function? So we want the function to, okay, so let's see. So the function signature is this, right? The function signature is that, and what we want to do is, we want to call map function on the current element, and we want to keep accumulating this, right? So we will take this and add it to our accumulator, right? So the accumulator is going to be the list, okay? So we'll add it to that list, okay? And that should do it. So let's create a few more tests here. I'm going to say describe enum.map. It should allow addition on elements, right? And if we say map. So I'm going to have an array is enum.toList 1 to 10, right? And if I say map this array, and the function is going to be x such that x is going to return x plus 1, and that should be equal to for now I'm just okay, so that should be equal to 1 to not 1 to 10 1 to 10. If you offset it by 22, that's going to give you 1 is going to become 3 and 10 is going to become 30, right? So we've got that. Okay, that's okay. So we've got a list here. Yeah, I could have just typed that. That would have taken the same time. Anyway, that's that, right? And if I run the test now, it says undefined function it. Oh, this is the Ruby influence in me. Anyway, all right. So invalid expression in match. Expanding macro assert. So assert this equals to, yeah, double equals to. And undefined function map. Why is that? We have a function map, and that takes two things, and we are importing it, right? Enumerable map function, enumerable map. So let me just do a mix compile first, just to make sure. Undefined function map to. Okay, so is there a typo somewhere? Naive enum dot map. Okay, undefined function in, okay, function naive enum map is undefined or private, and that's on line number 9. And oh, we didn't save this file. That's weird. Okay, so there's another error here, and yeah, that's weird. All right, so now it's all working, and we have 11, 10, and so on. Okay, so if you look at it, we're trying to map the array, which is 1 to 10, right? And we are adding 1 to it, right? So 1 becomes 2. And if you look at it, it's actually in the reverse order, right? So what we are doing is we are adding to the head, right? And the reason we are adding it to the head is because this is more efficient, right? So when you have a linked list like in Elixir, adding to head is simple. It's a constant time operation. Whereas adding to the tail takes, this is O1 and this is ON, right? So adding to the tail, and this is a head takes that, right? The big O notation, right? Anyway, so that's that. But what we need to do is, when we reach the end, we need to reverse it, right? So when we get this guy, we need to reverse this, okay? So how do we reverse it without using enum? That's an interesting thing. So I'm going to do a bit of cheating here, and I'm going to use enum reduce, okay? But we'll get to implementing the reduce function, and then we can get rid of that. Oh, it's not reduce, it's reverse, right? So we want to reverse the whole thing at the end. So now, what does it say? Enum reverse should allow function naive enum reverse is undefined. Okay, so elixir.enum.reverse. Okay, so there's still a problem. We are starting from 3, we're going till 13. That's obviously wrong, and what our code is actually doing is correct. So we could just copy this and paste it there. Okay, so many times this is what happens when I write tests. My assertion actually ends up being wrong, and I end up getting the actual value from the output and then using that. Okay, so now this is working, and let's write another small test for multiplication, and actually upcasing, right? So should be able to upcase. So so let's say naive enum map. Actually, we can say enum map and Haja Muju Zainab, right? We're going to take those guys, and here we're actually going to use the simpler notation of string upcase, right? And that should be equal to this. Only it should be upcased, right? Like that. And now if we run our tests, all of them pass. Awesome. So we've implemented map and reduce, and we've actually implemented reduce in terms of map. I'm sorry, map in terms of reduce. Okay. So we've covered a lot of ground today, and if you look at it, the code for the enum is very small, and the code for the tests is larger than that. But that's a good thing, right? That's a good thing. So so the only place where we are cheating is we're doing a reverse here, and we're using the actual enum module. So this is not good. We'll fix this in the next session. Okay. So till then, bye and have a great time.